Okay. So in our last lecture, we have started with the third unit, remote procedure call. And from that, around 5 bits we have covered already. Um, just we will take one review of all those points once again. So we have started with the introduction part of the chapter with a simple why we should go for RPC, remote procedure calls. So the features of RPC we have studied in the introductory part. Then RPC model, we have studied that RPC model. So how the message passing is being taken place between the caller and the callee. Caller, which is known as your client process, callee is nothing but your server process. How the message transfer is taking place, how you are showing your diagram with blocked and unblocked lines. So all those part we have already covered. Then transparency of RPC. So two types of transparencies, that is syntactic transparency and semantic transparency we have seen. So in syntactic, so the remote procedure call should have exactly the same syntax as the local procedure call that we have seen. Means in case of syntactic, both the client and the server, both the machines should have the same syntax of the procedure call. Okay, that we have seen with the example also last time. So we have taken the example of our laboratories, how we are going to call any particular procedure from another machine which is having same operating system and same all the things from which we are going to fetch a particular procedure. And second is the semantic transparency, which means that the semantics of the remote procedure call are identical to those of the local procedure call. So semantic in like the structure of your system, whatever the operating system, whatever the configuration you are using, so that should be similar one. So those two transparencies we have seen. Then um, we have gone through the implementation of RPC mechanism. Okay, so here the five main structures like the client stub, RPC runtime, the server stub, and the server. These five uh, different modules, how they are taking place in actual RPC mechanism, that we have seen one by one. So before that, we have seen this particular diagram. So here is the your client machine, here is your server machine. From the client only you are sending one particular call for procedure to be fetched from the server. So this call will be packed at the client stub, and then it will be sent to the RPC runtime present at the client machine. So this occurrence of RPC runtime is there at both client as well as the server side. So this packed message is coming from the client stub to the RPC runtime. So this will be sent as a packet, call packet, to the RPC runtime present at the server side. Then this packet will be sent to the server stub, which will unpack your message, and then it will send to the server where the execution of your call will take place, and then the result of the procedure will be returned to the server stub again. Here at the server stub, again your uh, data which is coming from the server will be packed again. Then it will be sent to the RPC runtime present at the server side, and then this resulting packet will be sent to the RPC runtime present at the client side. Now this will again send it to the client stub where it will unpack the result, and then the result will be given back to the client. So in this way your RPC mechanism will be taking place. So the features of all, that is the client stub, both sides RPC runtime, the server stub and the server, all their tasks we have seen already. And then the stub generation, how we are going to generate the stub. So it is having two different ways. First is the manually and second is automatically. So in case of manual generation, the RPC implementer provides a set of translation functions from which a user can construct his or her own stubs. So this method is simple to implement and can handle very complex parameter types. So here you are going to manually generate your stubs. And how automatically? So this is more commonly used method for stub generation. It uses interface definition language ZDL, that is used to define the interface between the client and the server. IDL, interface definition language, means how you are going to interact with each other, which particular language you are using over there. So that matters much over here. So here it generates your stubs automatically. An interface definition is mainly a list of procedure names supported by the interface together with the types of their arguments and the results. So this is sufficient information for the client and the server to independently perform compile time, type checking, and to generate appropriate calling sequences. However, an interface definition also contains other information that helps RPC reduce data storage and the amount of data transfer over the network. Okay, so why this one is important, or why how automatically stub generation is taking place? So just like um, you are calling one particular method from the server side, so it will be having the, say for example, two number of arguments which both are having integer parameters. But here from the client side you are sending the request for both float type of data. So your server should be um, flexible enough, or you should provide the mechanism for your server that to handle each and every request coming from the client and process them automatically. So this is how the working should be done. So all your request coming from the client should be clear enough and giving the proper result. Then coming to the RPC messages, which is our today's first bit. RPC messages. The two types of messages involved in the implementation of RPC are as follows. That is, the first one is call messages and the reply messages. So, for all these RPC, what two different types of messages we are concentrating for? So, that is call messages and reply messages. So, what is call messages? So, that are sent by the client to the server for requesting execution of a particular remote procedure. So these call messages are coming from client to the server. Okay. And of course, opposite to that is your reply message. So that are sent from the server to the client for returning the result of the remote procedure execution. Okay. So whatever the task done for the call message coming from the client, server will do his task of fetching the particular procedure, calculating the result, and giving back to the client. So that will be sent by using the reply message. An RPC protocol is independent of transport protocols. That is, RPC does not care how a message is passed from one process to another. Therefore, an RPC protocol deals only with the specification and interpretation of these two types of messages. So, the call messages that are coming from the client to the server, that are having some specific format. So, the format is shown in the diagram. So, it will be containing the message identifier, message type, client identifier, then remote procedure identifier, which is divided into three parts, that is program number, version number, and procedure number. And after that, the arguments. This symbol is showing n number of arguments, which will be from 0 to many. So that's why you are showing it by using this symbol. Okay. Since a call message is used to request execution of a particular remote procedure, these are there are two basic components necessary in the call message, which are given over here. That is the identification information. The first is identification information of the remote procedure to be executed, and secondly the argument necessary for the execution of the procedure. So overall your call semantics or the call messages are depending on these two, mainly these two factors. The first is identification information, that is nothing but this one, remote procedure identifier, which is having the information related to the program number. Means what? Whenever your request is coming from the client to which particular program, you have to find that particular procedure. So that program number with version number and the procedure number. Procedure number means what? If I am calling, say for example, addition, so add something in bracket integer integer I have written, so your control directly should go to that particular procedure only. So all this information will be stored here with the remote procedure identifier. So this identifies the program number, version number, as well as the procedure number. Okay, so this is the first field. Then second is the arguments. That is nothing but the field that is necessary for the execution of the procedure. Means whatever the basic data or raw data you are providing from the client to the server, that will be there in the arguments field. Then in addition to these two fields, a call message normally has other three fields, and that are message identification, message type, and client identification, which are given over here. So the first field is message identifier. So this field consists of a sequence number. What is sequence number? So suppose from client, your one particular server is there and you are having, say, uh, three machines as a working as a client, so A, B, C. So first of all, A will be sending you the data, then after B is requesting the data, then B is requesting the data, and C is requesting the data. So all this information will be queued somewhere, and then for which particular request A has given you the request message, that will be fetched, and its according reply message will be sent to the machine A, that is your client A only. So all these fields should be maintained properly, and that's why this message identifier field is there. This field is useful in two ways: for identifying the lost messages as well as duplicate messages. आता तुमचा क्लायंट कोण आहे तो पण तुम्ही ओळखणार आहात, त्याचबरोबर लॉस्ट मेसेजेस. सपोज फॉर एक्झाम्पल यू हॅव सेंट वन पर्टिक्युलर मेसेज but it has failed or lost somewhere. How the loss of messages is taking place, that we have seen in second chapter prior. Okay, so if that message is getting lost, so you have to generate the request for the same message once again, right? So accordingly that particular request will be fetched. Or else suppose you are sending one request twice or thrice, then at that time also you should be able to handle your request, that or identify this particular message is coming twice or thrice in that way. Okay, so to identify the lost messages as well as the duplicate messages, you need to have the field of a message identification. So in case of system failures and for properly matching the reply messages to the outstanding call messages, so especially in those cases where the replies of several outstanding call messages arrive out of order, so that time the field of message identification is taking a very important role. Then the next one is the message type. Message type, this particular field. So why it is used? This field that is used to distinguish call messages from reply messages. So for example, in RPC system, this field may be set to 0 for all the call messages and it will be set to 1 for all the reply messages. So जो कुठला मेसेज तुमचा ट्रान्सफर होणार आहे, so this field will identify whether it is a call message or reply message. So some kind of identification you have to decide. So for example, I have decided 0 is for call messages, 1 is for reply messages. So that way you will be differentiating both of them. Then the last field is client identification, this particular field. So this field that may be used for two purposes: to allow the server to the RPC to identify the client to whom the reply message has to be returned, and to allow the server to check the authentication of the client process for executing the concerned procedure. So which the example which just now I have given to you, suppose I am getting the request from machine A, then I have to reply give reply to machine A only. My reply should not go to the client B or C. It should be diverted properly to the machine A only. So this will be identified by using this field, that is the client identifier. So in this way, 5 fields are there in your call messages. So the question can be asked, explain the typical RPC call message format. So at that time you have to show it with the diagram and the explanation of all these 5 fields. After this, the second part, that is the reply messages. When the server of an RPC receives a call message from a client, it could be faced with one of the following conditions. So reply message will go with some conditions and that are listed over here. Might be it will not be viewable on the slide, but it's okay, not an issue. So the conditions may be, the first one, that is the server finds that the call message is not intelligible to it. This may happen when a call message violates the RPC protocol. So obviously the server will reject such type of calls. Means you are getting the request from the client which are not up to the mark intelligible. Means there may be chances you are fetching one particular procedure which is not having sufficient number of arguments, or that particular procedure is not found at the server, so your client is not intelligible in that case. Second is, the server detects by scanning the client's identifier field that client is not authorized to the service. So the server will return an unsuccessful reply without bothering to make an attempt to execute the procedure. So suppose if you are getting the request from such a client which is not at all part of your network, or which will be having some um, what we can say, uh, illegal data which is coming as an argument or so from the call messages, which will be harmful for your server. So no matter here the server will not at all execute that particular procedure, and directly he will send the unsuccessful reply message to that particular client. So this is the second condition. Third is, the server finds that the remote program version or the procedure number specified in the remote procedure identifier field of the call message is not available with it. So again, the server will return unsuccessful reply without bothering to make an attempt to execute the procedure. Suppose server is not finding the procedure or the version number which is specified by the client with the server, then what will he do? He will directly send the unsuccessful message to the client, okay, without attempting to execute the procedure. So this is the third condition. Fourth is, if this stage is reached, an attempt will be made to execute the remote procedure specified in the call message. Therefore, it may therefore it may happen that lecture is going on. Just excuse for 1 minute for me. Okay, so the next condition is, um, the fourth one is, if this stage is reached, that means an attempt will be made to execute the remote procedure specified in the call message. So therefore, it may happen that the remote procedure is not able to decode the supplied arguments. So this may happen due to an incompatible RPC interface being used by the client and the server. So if both the machines, that is your client and the server, are not compatible with each other, so at that time the request will not be processed properly. So that time it will send an unsuccessful message to the client. And the next one is, fifth condition is, an exception condition such as divide by zero or such any kind of exceptions if occurs, then while executing the specified remote procedure, the server will send the unsuccessful reply message. Okay, so these five conditions are there which will be sending the unsuccessful reply messages, and the sixth condition here is giving you the successful message reply. How? The specified remote procedure is executed successfully. That means the requested procedure from the client is found at the server side, then that will be processed properly, and its respective result will be sent back to the um, uh, client. Okay, so obviously in the first five cases which we have already discussed now, an unsuccessful reply has to be sent to the client with the reason for failure in processing the request, and successful reply has to be sent in the sixth case with the result of the procedure execution. So therefore, the format of the successful reply message and unsuccessful reply message is normally slightly different. So a typical RPC message format for successful and unsuccessful replies may be of the form shown in the figure over here. So this particular first diagram is showing you a successful reply message format, and B is showing you unsuccessful reply message format. So how unsuccessful? So we have discussed the five cases over here. So it will be including, that means your unsuccessful reply message will be including message identifier, message type, reply status, like whether it is successful or unsuccessful. Here in unsuccessful, it will be unsuccessful message format. Then reason for failure. What is the reason behind sending the unsuccessful message format over here? So that reason will be sent over here. And then your successful message format will be there, which will be including again the message identifier, message type, reply status as the successful, and its result. Means after executing that particular um, uh, procedure, whatever the result of the procedure is there, that will be sent back to the client by using this particular result field. Okay, so again this result field is shown with this particular symbol. Why is that so? Because the result may vary in the length. That means it will be having just 1 bit, 2 bit, or multiple bytes size the result could be there. Okay, so this is the reply messages. Any doubt till now? Is everything clear with you all? Yes, any doubt? Reply me in the chat window. Shruti Kaude, any doubt? Okay, so we'll go for the next bit, that is marshalling the arguments and the results. So the transfer of message data between the two computers require the encoding and decoding of the message data. So for RPCs, this operation is known as marshalling and basically involves the following actions. So whatever we call it as a encoding or decoding, encryption and decryption of data. So here in case of RPC, it is having just a different name as marshalling of the data, marshalling of the argument and the results. So it involves basically some actions for that. The first is taking the arguments of the client process or the result which is coming from the server process, and that will form the message data to be sent to the remote process. Secondly, encoding the message data of step number 1 on the sender's computer. So this encoding process involves the convention of program objects into a stream form that is suitable for transmission and placing them into a message buffer. And third step is decoding of the message data on the receiver's computer. This decoding process involves the reconstruction of the program objects from the message data that was received in stream form. Okay, so this way, in these three steps your encoding of the message and decoding will be done. So first of all, you have to take the arguments which are there from the client process or the result if you are dealing with the server process. Okay, and then in the second step you have to encode that particular data. Okay, and third step will be according to the machine. That means if it is the arguments which are there from client side, then you have to decode it at server side, or if it is the result of the procedure from server side, then you have to decode it at the client side. So the first is take those arguments or the result, second encode, and third is decode that particular message data. So, in order that encoding and decoding of the RPC messages can be performed successfully, the order and the representation method, that is, if it is tagged or untagged, as per the choice may be, used to marshal the arguments, and the result must be known to both the clients and the servers of the RPCs. This provides a degree of type safety between the client and the server, because the server will not accept a call from the client until the client uses the same interface definition as that of the server. So that's why the marshalling process must reflect the structure of all types of program objects used in the concerned language. This includes some primitive types, structured types, and user defined types. Okay, so as we have already seen that your machines in case of RPCs should be having syntactic as well as semantic transparency. So this will come into picture in this bit as well. Okay, so thus this marshalling procedure may be classified into two groups. The first one is those provided as a part of RPC software. That means normally the marshalling procedures for the scalar data types together with procedures to marshal the compound types built from the scalar ones fall in this particular group. And the second is those that are defined by the users of the RPC system. So this group contains marshalling of the procedure for user defined data types and data types that include pointers. Okay, so in this way the marshalling will be done in these two groups. Next is server management. So for all these procedure, how you're going to manage at the server level all the things, so that we are going to see now. So in RPC based applications, two important issues that need to be considered for server management are server implementation and server creation. So the first is server implementation. So based on the style of implementation used, server may be of two types, that is stateful and stateless. So first step, as we are going to see, that is the server implementation, and second is the server creation. So server implementation, which is again divided into two types, that is stateful or stateless. Okay, so each one of these we will see now. What is stateful server? So the stateful server maintains client's state information from one remote procedure call to the next. Okay, so one particular call if you're getting from your client, so till he's sending another procedure call, the server will be maintaining the state of your client. That is, in case of two subsequent calls by the client to a stateful server, some state information pertaining to the service performed for the client as a result of the first call execution is stored by the server process. मग आता हे तुम्ही कशा पद्धतीने सेव्ह करू शकता? सो मे बी सम काइंड ऑफ acknowledgement you will be accepting from the client machine. That means you are getting some call for a particular procedure. Server will act on that particular call. He will send the reply message, and then if he is waiting for the acknowledgement from the client side, so ultimately he is waiting for the reply, as your client is in the state to accept your request. Okay, so these clients state information is subsequently used at the time of executing the second call. Means here now if I am getting the acknowledgement from the client, so I can say that, means as a server I can say that he will initiate another request. Okay, means is in the position to send one another call to me, and that will be processed now. So for example, let us consider a server for byte stream files that allows the following operations on the file. So the operations are like open. The first is open. So for this, the arguments will be the file name and the mode. So this operation is used to open a particular file identified by the file name, obviously, okay, as it is there in the argument. When the server executes this operation, it creates an entry for this file in the file table that it uses for maintaining the file state information of all the open files. The file state information normally consists of the identifier of the file, the open mode, and the current position of the non-negative integer pointer, which is called the read-write pointer in this case. When a file is opened, its read-write pointer is set to 0, and the server returns to the client a file identifier which is used by the client for subsequent accesses to that file. So suppose for example, I am asking for one particular file named abc.txt by giving that name by using this particular argument, and I am giving the mode as a read mode, then automatically that file name means or the file table entry which is present at the server side will get the entry that my abc.txt file is now in open mode, and the cursor is set at this location. So as I have opened it in the read mode, so that means my cursor will be at the 0th bit. Okay, so if I'm opening that particular file in a write mode, then it will be at which location in case of write mode? At the 0th position or at the end of the file? Yes, no one? You are opening a particular file in a write mode. So at that time, your cursor will be at 0th position. That means you are going to read the content first. If you are opening it in the write mode and try to write something or try to type something over there, then the first letter may get um, inserted by another letters. Okay, insert operation. Hope you remember the insert operation in our C C++ editor. Okay, so that means old data will be replaced by the new data which you are typing now, right? And if you are opening your file in append mode, at that time the cursor will directly go to the end of the file and then writing operation will take place. So all this information will be stored at the server, which particular file is open, and it is present or it is open in which particular mode, at which particular location the pointer is right now set. Okay, so this all will be there with the open operation. Second is read. With this I will be sending FID, that is file id and the buffer, these three arguments. So this operation is used to get n bytes of data from the file identified by FID into the buffer named as buffer, that is our third argument. When the server executes this operation, it returns to the client n number of bytes of file data starting from the byte currently addressed by the read write pointer, and then increments the read write pointer by n. Okay, so as in how you are going to read that particular data, the number here will be increased by 1. Then next function is write. It will again be having the same number of arguments, that is FID, n and buffer. On execution of this operation, the server takes n bytes of data from the specified buffer, writes it into the file named by FID at the byte position currently addressed by the read write pointer, and then increments the read write pointer by n. Okay, so whatever data you are sending by using this buffer, that will be returned at the location present, or at the location which is now pointed by your pointer. This pointer will be showing you the read write position of the pointer which is present in your file table entry. Okay, next function is seek function. It is having the arguments FID and the position. So this operation causes the server to change the value of the read write pointer of the file identified identified by the FID to the new value specified as the position. Okay, so here you will be setting the uh, cursor's position to the position given by the argument field. And finally, the next function, that is the close, which is having the argument of FID. So this statement causes the server to delete from its file table the file state information of the file identified by the FID. Okay, so whichever file you have opened and its entry is there as a means its entry is there in the file table. So after putting the close with that file id, that entry will be deleted. That means all the operation on that particular file are now stopped. Okay, so this particular diagram will be showing you the example of stateful server. So here is the client process and the server process, which is having the file table with the entries of FID, mode, and the read write pointer. Okay, so here if the client is asking for open operation, then its entry will be done over here, and according to that entry the FID will be sent back to the client. Now again, read operation, it will be written here in this example, read FID 100 comma buffer is set. Okay, so 100 is what? 100 is the size for this particular buffer. So from 0 to 99 bytes will be read, and those will be returned as the argument back to the client. Again, if I am calling the same function read FID 100 buffer, then after 99th location, that is from 100th to 199th position, the data will be sent as the result. Okay, so according to this the file table will be maintained. So this is the example of stateful server, where each and every requests will be stored in the file table entry which is present at the server side, server process. Okay. And then the next type, that is the stateless server. So the stateless server does not maintain any client state information. Therefore, every request from the client must be accompanied with all necessary parameters to successfully carry out the desired operation. For example, a server for byte stream files that allows the following operations on the file is stateless. So the first operation is read operation. So read will be having four number of arguments, that is the file name, position, n, and the buffer. So on execution of this operation, the server returns to the client n bytes of data. Okay, this n bytes of data of the file identified by the file name. So the return data is placed in the buffer named as this one. So whatever the argument you are sending, that name will be given to the data over there, and the value of the actual number of bytes read is also returned to the client. So the position within the file from where to begin reading is specified in the position parameter. कुठून पासून सुरुवात करणार आहे, किती नंबर ऑफ बाइट्स मला रीड करायचे आणि ही सगळी इन्फॉर्मेशन कुठे स्टोअर करायचे, तर त्याचं बफरचं नाव as well as the file name, all this information will be there in your read function. And then next is the write function. So write, it is having also the file name, position, n, and the buffer. So when the server executes this operation, it takes n bytes of data from the specified buffer and writes it into the file identified by the file name. The position parameter specifies the byte position within the file from where to start writing. So the server returns to the client the actual number of bytes written. Okay. So this figure is showing you the example of stateless file server. So client server process and server process is there. So this information now is maintained at the client process only. So here in this case, server will not be having any entry as that is there in case of server, that is file table. So now the file state information is present at the client side only. So whenever you are sending the data for read, so accordingly check the number of arguments over here. So file name you are sending, position from which particular byte you are going to start for reading the data. So that is 0 to 100 and you want to store it in the buffer. Okay, so according to that 0 to 99 bytes of that file will be returned to you. So now I will be having, as a client, I will be having the data that my particular, this particular file name file is having 0 to 99 bytes with me. Now I want 100 more bytes of data. So again, I will ask the read operation with the same file name. Now I will be starting, I will be having the starting position at 100. From 100, next 100 bytes I want in the buffer. So now it will return me the 100 to 199 bytes of a data. So overall for that particular file name, now I will be having 0 to 199 bytes of data. So all this information will be stored at the client process only and not at all at the server process. So this implementation is nothing but the stateless server. Okay. So now why to go for the stateless servers? So the stateful servers provide an easier programming paradigm because they relieve the clients from the task of keeping track of the state information. As we know, in case of stateful server, all the information is stored at the server side, so there is no need to save any file related information at the client side. Okay, but stateful servers are typically more efficient than that of the stateless server. That is also agreed. But stateless servers have distinct advantage over the stateful servers in event of a failure. But suppose, for example, if your server machine is getting crashed because of some means, at that time, whatever the information that is there with the client, it will be with him only. Okay, so no any entry mismatch will be there at the server side. So keeping track of the information of your respective file from the client side will be more and more easier in case of stateless server. So suppose, for example, with stateful server, if a server crashes and then restarts, the state information that it was holding may be lost, and the client process might continue its task unaware of the crash. So it may produce inconsistent result. So there may be chances of getting replicas of the same result which may conflict the result of the operation present at the client side. So similarly, when a client process crashes and then restarts its task, the server is left holding the state information that is no longer valid but cannot easily be withdrawn. So therefore, the client of the stateful server must be properly designed to detect the server crashes so that it can perform the necessary error handling activities. But this task it a bit difficult to implement. Also, on the other hand, with the stateless servers, a client has to only retry a request until the server responds. So it does not need to know that the server has crashed or the network temporarily went down. So therefore, stateless servers which can be constructed around repeatable operations make crash recovery very easily. So that's why the main purpose of crash recovery is being done or is being carried out by using stateless server. So we can say that maintaining the information with the stateless server is more and more feasible. So any doubt till now with the stateful and stateless server? Yes, you can put your replies in the chat window. Any doubt? Okay. I think many of the regular students which are most talkative are absent today. That's why I'm not getting much more response in the chat window. But it doesn't matter for you all. You should also be in the condition of stateful, not stateless. All right. Then the next one is so the two points in case of server management which we have seen prior. Uh, here. So server management is done with the server implementation, and the second is server creation. So the server implementation just now we have seen with the help of stateful and stateless servers. The second is the server creation semantics. Okay. So based on the time duration for which RPC servers survive, they may be classified as a instance per call servers, instance per transaction or session servers, or persistent servers. So the first is instance per call servers. So here the servers belonging to this category exist only for the duration of a single call. Okay, one particular call is coming from the client for that procedure only. Procedure in case like you are getting the request, sending its result for that particular call only, your server will be existing. So a server of this type is created by the RPC runtime on the server machine only when a call message arrives. The server is deleted after the call has been executed. So this is the first type, that is instance per call server. Second is instance per session server. So what does it mean? Server belonging to this category exists for the entire session for which a client and the server interact. So since a server of this type exists for the entire session, it can maintain inter-call state information and the overhead involved in the server creation and destruction for the client server session that involves a large number of calls is also minimized. So in the first instance per call, you are getting number of calls in this particular type of server, but those will be minimized for the second category, that is instance per session type of servers. And the third category is persistent server. So what does it mean? A persistent server generally remains in existence indefinitely. Moreover, we saw that the servers of a previous two types cannot be shared by two or more clients because they are exclusively created for a particular client on demand. बरोबर आहे. जो पर्टिक्युलर क्लायंट या ऑपरेशन मध्ये इन्व्हॉल्व असणार आहे तोच फक्त ह्याच्यामध्ये ऍड केला जाईल. बाकी सगळ्यांसाठी बाकी इतर other than that particular client server, for other clients it will not be there, that instance will not be there. So this will not be the condition in case of persistent. So unlike them, a persistent server is usually shared by many clients. So these are the three types of servers: instance per call, instance per session, and persistent server. Okay, so with this particular bit, we will stop over here. So we are at this bit, server management, we are done with, and with we are left over with parameter passing semantic, call semantics, communication protocols for RPC, client server binding, exception handling, and the security. Okay, so we will stop here. So now, any doubt till now? With these points, if you have any doubts, you can post your queries. All right then. So keep all the instructions which are given to you at the start of the lecture. And now you can put your attendance in the chat window, and you can left the room. Thank you very much.